WATS live webinar where we're going to be talking about AI and the use of AI agents to create WATS converters or do any other kind of integration with WATS for that part. This is going to be an exciting one. I don't know exactly in which way, but we'll probably find out during this session. So what we'll try to do is to showcase a typical workflow that I would use or that my team would use to do a converter development project. Unfortunately, we're very short on time, so this should ideally be a 3-hour session, but it's a 1-hour session. And as you probably have seen, I might be extending that 1 hour for a little bit. But we'll try to do the best of the time we have. So it will probably be a little bit quick. There will be a recorded version that you can replay in half speed afterwards. And the main point is to hopefully be able to show you that it's possible. It makes it possible for someone with little or no knowledge to development to actually make small scripts like typically a converter is. So I'll just dive into it. With today's session, there is handout. There is a document in this webinar, which is essentially an installation instruction for our converter development toolkit that's available on our GitHub account. Okay, so let's just dive in and look at what we are going to do today. First of all, I just want to mention a couple of things. Because of this complex topic and limited time, I'll be quick. I will not have the time to do in-depth explanations. The webinar might exceed the planned 1 hour, and completing the project is somewhat unrealistic. Proof of concept is the main goal. So please wish us luck, and let's hope that the AI agents are on our side today. The topics we will cover, and not necessarily in this order, because we will have to adapt to whatever happens. But first, we're going to look a little bit at the project setup and how to get started. Then we're going to do a brief, or in between everything, we're going to do introductions to the tools. So we're going to talk a little bit about what Vision Studio Code is, what GitHub and Copilot is, and what the dev kit provides. This will just be touching the surface. The main part will be the live implementation, which we will start almost immediately, and hopefully it will be ongoing through the hour, and hopefully it will also produce something. And then in between, should there be time, I can share some of my experience with the AI agent coding and the do's and the don'ts. And to give a little bit about my background for those who haven't met me before, my name is Ola Lund Reppe. I am integration architect at WATS, and I would say I'm a coding enthusiast and a hobbyist, and I've been working with development my entire life. So usually as a developer or somewhere in between technology and people, like project management and these kind of things. So I have a fairly good understanding, and I have background all the way back to assembly programming. C++ is maybe my main language, and I've been working with mostly Microsoft Stack all my life. Last half year, I've also been working Python and cross-platform. So it's exciting for me, and also to see the possibilities and maybe the pitfalls that this provides, and it's definitely exciting, and it would be stupid not to take use of it. That's at least my conclusion for now. So first, let's look at how to get this started. So we're first going to clone and set up the project. So the project exists on our public Git page, which is this one, github.com/Virinko, and GitHub is simply a place where you can store and collaborate on source code. A lot more than that, but let's leave that for later in the session. So on top of the list here, there's a WATS dev kit, and you can see it's a public template. So it's not, you're not really supposed to clone it. If you clone it the regular way, you will get a version that's linked to this repo. And since you're not a user, you'll not be able to use that. So the advice way to do this is to go here and use this template and create a new repository. And then you'll be taken to your GitHub account, which is one of the things necessary to use this. Is that you have to register for a GitHub account, which is free. So I will put this one in the template, and I will put it on my personal account, and let's call it AI webinar. And I'll clone it as a private repository. That means that we can see the code. Here I actually have the chance to start the AI coding already, so I could give a prompt here to get the agent started. In my case, I don't want to do that because I can't really do anything before the files are downloaded locally and I'm working locally. So we'll just create the repo. Now you can see this is showing up here. And now this is a repository made from the templates that we found on the Virinko page. So now you can see I'm not on Virinko anymore, I'm on my private account. So what we want to do now is to clone this and open it in Visual Studio. So I'll go to the code and I can simply copy this link and I will start my Visual Studio code. Now this original template was open. So before we start, I will go close folder. And then we're going to clone a Git repository, and I paste in the link from my GitHub. And now I'm asked to choose a location for the files. So let's go to, it's located here. So now this downloads the files from the GitHub repository and sets the project up locally. And I'm asked to open the folder containing the project, and now it's open. And all these steps that I'm explaining now are explained in the documentation that follows this project, so it should be pretty simple to follow. So once we're in here, just like the documentation says, we can run a setup script, and the setup script and everything in here really now is not necessary to make this work. We could have started Visual Studio Code with no documents, opened it, an empty project, and started typing into the AI chat, and you would get that to work. You could start typing, I need to make a converter for WATS clients and the version, and ask the agent to search the web and try to find DLLs necessary and try to explore how to use the API. That would lead to a lot of trial and error. So instead of doing that every time, this project kind of gives the agent everything it needs. So it has explained the structure of how a converter is made. It has explained how the API is used, how to create a UT report, how the different step types works, and so on. So this is not only for the agent, this actually is an excellent documentation if any of you are writing converter code with traditional manual coding. So for the API, there's a UT and UR section, and there's detailed explanation for everything the converter will need. And also inside this project, there is a lot of smart little tools that can help the workflow, that can tighten up things a little bit and make it a little bit safe. but I need to stress that they are not important at all. The main thing to succeed in using this tool is your communication skills with the agent, your ability to explain in clear terms what you want to achieve, and a structured working habits. That's the main thing. That is more important than any other tool you can set up. So you will find some of the tools you will find in this tool set. Here there are different PowerShell scripts that does different things, sets up a new converter, packages gets the operation types, packages, and releases the converter, and so on. And then we have see some guides as well. And in the source code directory, there is an example project, an example converter, and there is a test setup for this one. So let's just go ahead and keep in mind that you don't have to understand much of Visual Studio Code. It of course helps, but you can do everything with prompting. And I'll try to do that today. I'll try to not touch any buttons or do any shortcuts with anything. So I'll start by, can you please, and I'll be overly polite. You never know when they'll take over, so I'll not take any risks. Can you please run the setup scripts? Now we'll just let that work on that setup script, and it's also a good habit, at least if you're working on something with some kind of complexity, to pay attention to the output in the chat log, because at least when you have some understanding about the APIs used in this case, when you catch that it's going down the wrong path, you can stop it and correct immediately, and you'll save yourself a lot of time. Also, when you're using this chat, there is a lot of different settings. You can run it in the cloud, you can run it locally like I'm doing now, and you can also run it in a background process. So that opens up for a lot of possibilities for parallelization. So you can do one thing in the background while you're working locally on a different issue. I would also warn that this complicates things and it introduces a lot more risk, because you will have to merge those code bases together and yeah, so containing things and doing things that can be separated and will not affect other parts of the code is advised if you're doing that. Okay, so it's running my script and it says that it completed successfully, so everything is here. What it has done now is it's got the DLLs for the client. It has checked that my client is running, and it checked the version and that we are using the correct SDK. So this tells me that the WATS 7 is installed on my computer. And now it says I can run the new converter command to create a new converter. So new converter, this is one of the tools I was describing, and this is called a prompt file. So it's essentially just a file with a text prompt with instructions for the agent, and that is made into a command. So when I write new converter, it will essentially know what to do when making a new converter. I can fill in what I want to make, but in this case I can just press enter as well, and then it will query me for the information it needs. So if I typed in everything, it wouldn't have done that query, but now that it starts running the script, it will type out here, and it's a bit hard to see, but in the lower end here it says assembly name, and that's some background information about converters. So a converter for the Windows client is a DLL, which is a package of compiled code, and the DLL needs a name and an identity, and inside that DLL there can be one or more converters. So the first thing I'm naming is the DLL, and in this case today we're going to try to make a converter for a format called TDR. So I'll call the assembly TDR converters, and I'm asked for the name of the converter, and I'll call that TDR text file parser. And then I'm asked to give another name if I want to make more converters, but I won't, so I'll just click enter, and I will set up the project for me. So now it's created the project. You can see here it's in the TDR converters. It's created the source directory with the project file and the class file, and then it's generated the tests. Yeah, so now you can see here the test will fail if you run them because we haven't done anything. It is not really testing anything. So at this point, the next step is to start finding a strategy for the conversion. So let's go a little bit back here and look at how this process typically is done. And this is more or less the same doing AI as conventional coding. So the first part is to understand the file format. So traditionally, we had typically open some samples of the source files, and then we scan through them and try to understand the patterns of the formats. How can we parse this in an understandable, in the best possible way? With AI agent, this has been this is a lot easier because the AI agent can scan through a big set of source files and easily understand the full variation, the full picture of the variation that occurs. This has been really hard doing manually, so we could at tops just do that manually for 5 to 10 files, and then we'll have to do test runs and check things when the data is uploaded, which will mean that sometimes we'll have to go back and do major changes. But now we can do that in a few minutes, do a full analysis, which is usually a lot better than I was ever able to do manually. Next step is to make an implementation plan. So what we typically do here is that we look at the analysis and then we do a sanity check, make sure there are no hallucinations or any stupid mistakes, correct them, and then ask the agent to make an implementation plan from this. And from the implementation plan, we do the actual implementation, and we do them in stages. Yeah, and how big those stages are is of course up for discussion. They can be pretty big, and in a converter example, they can actually be just 1 or 2 or 3 stages. So if this was a simple CSV format, it's not impossible to do a one prompt, let the converter work, and have an almost working converter at the end. This is not a simple CSV file, so that strategy is not possible. And then testing and validation. So test frequently and validate at every stage. So that's what we're going to do now going forward. So I'm going to go back to Visual Studio in here, and then I'm going to find my files. And I'm going to simply drag and drop all my test files, and I've been sure to bring a big variation. I will bring them into converters, into my TDR converter. Oh, this was tricky, and into the into the tests and into the data folder. So this is the report that will be used when the tests run, and we can open one of the report files to look at the format. And we can see it's a typical text format. It has pipes for separators, some header data, and it has a sequence. There seems to be chart data in here. Yeah, so this looks structured and absolutely doable, but also with a lot of different details. So it's not that simple. So now that we have the files, let's go back and have a look here and go one step further and look at what we do for the initial prompt. So what I'm going to do now is to make the very first prompt, which is about analyzing the test files and trying to link them to WATS UUT reports. So I'll start by something like, can you please start doing a header evaluation using UUT head skill, which is one of the tools I'm referring to. So I've created a UUT head skill that has references to how to build a header, what details should be included and what should not. This could just as well have been replaced with using the documents UUT reports in the project folder. So, and usually the agent will be able to find a lot of this information without you explicitly telling. But by explicitly giving the context, you will drastically reduce the risk of the agent misunderstanding. So I'm asking you to use that skill to make a TDR header analysis MD. So this is just a text file holding the markdown file holding the analysis, where you first analyze the example files. And here I'm referencing two documents. Use the header properties and header containers. This is probably a little over the top. The agent will probably manage this on its own to propose a mapping from the source TDR to WATS UUT. And then in this stage, only evaluate the header section. This is about doing the things in steps, not making things too complicated, not for the agent and not even for you to stay in control. And then it's asked to leave the sequence and the steps for later. So make sure to get all these actual test operations from the WATS server, just some details, evaluate the confidence of your mappings, and list the property mappings. And for debug purposes, and this is a good tip, when you do this debug of a converter, you need to submit those reports and you need to log into the WATS to look at those reports. And often this will include overwriting reports, because in the end you're uploading the same reports over and over again. And with a few seconds to a worst case a few minutes delay when something is lagging on the server or when something is queuing up, it can be hard to be sure that you are reviewing the last actual file. It could be that it's being processed and you're looking at the last run and you don't get that a fix is done or that something is wrong. So just a little moment, yeah. So what we do for debug purposes here is that we add into the report some information about the converter and the version and the time the conversion was done, because the start time will not help us because that will be constant from the test execution start. But this will tell us somehow that this is the last run. I also want to know how many files, what's the pass-fail count among them. That will help me debug. So if I expect 10 failures and I see 10 failures, and then that's a good indication. So now let's do that prompt and get the agent started. Unfortunately, this is taking way too long. But I'll switch back to here. And then we'll simply type this in to my prompt. Like this. So this is more or less identical to what we looked at in the slide. And we'll let that one work. I will do this one out of the window. And we can do that. Yeah, so while this is working, making the analysis, let's go to the next step right away. So we're done talking when the agent is done working. And this is exactly about that. So this is about a little bit about improving your workflow even more. So now, since the agent is working minutes, 5 minutes, 10 minutes at a time, it's often usually good to plan your work so you can do the manual work you need to do while the converter is working on something else. So in this next prompt that we are preparing, I will do something like this while I'm reviewing the step header analysis. Please now do a TDR sequence analysis using the UTSEC, which is another skill telling about how to build sequence calls, referencing the file's step types and referencing the file advanced, which has some advanced steps, to the analysis of the sequence part. Focus on categorizing the TDR steps, sequences, measurements by their type, data type, and contents, and find mapping from TDR sequences items to WATS step types. Keep in mind, this is something that usually the agent misunderstands, so that's why I'm bringing it in. So the main sequence callback, the root sequence in WATS, is created when the report is created. So to avoid the agent making a new root sequence call inside that root step, I bring in this little line. And then this is because I can see from the file format that all the steps has their own status. I choose to use the API test mode, and the API test mode set it to import. It's can be set to import or active, where active will evaluate the measurement against the limits and set the status based on that. In import mode, I am asked to set the status explicitly. The drawback of the import mode is that you can actually set deviating status. So you can have a measurement outside the limit, but still a pass, or vice versa. So, but I'm willing to risk that the source file is correct and simply use that import mode and trust that status. Okay, so then we have the next prompt ready, and let's just hope the agent is soon ready with analysis. Is working on counting up the passes and fails and so on. What we can do while we're waiting is we can go ahead. Yeah, I missed that point actually. The last part of the next prompt is make a converter parameter. That's called include step numbers, true false with default to true. That prepends the step numbering from the TDR file to the step name. So there's a numeric index segment in the start of each of the TDR steps, so that can optionally be included in the WATS report. So let's skip the tools for now and have a quick look at agent do's and don'ts, because this is actually going to be a lot easier than most people expect. So I first realized this when we started talking about MCP servers. So an MCP server is essentially something that sounds really complicated, that's meant to let the agent work with your API or work with your application. Until I realized that since LLMs, AI, can speak natively with humans in our language, these MCPs are simply human understandable text. So it's simply like the documentation in this project. There is no set rules for exactly how you should do it. There are recommendations, and of course, better ways to do it than other ways. But that's maybe the most important lesson from this session, if you have no experience with AI coding or AI agents, is that it's a softer approach to things. So essentially, you can use common sense to a large extent. And if you're good at asking questions and good at kind of understanding the concepts, then you can get a long way without any background information or background skills. So first thing I want to mention is restricting agents. This is not that relevant for converters because the project is so small, but working on a bigger code base, this is a very important point. You can see now that the agent is completing the work, but we'll we'll finish the restricting agents, and then we'll go back to the agent. So it's tempting when you do development because you have habits and you have assumptions. So it's tempting to have an idea of how something should be implemented and then try to tell the agent how to actually implement it. This is bad practice of several reasons. First of all, your assumptions and your ideas on what the best approach is most likely not the best approach. So that's the first thing. And the AI agent, although I'm not claiming that they're smarter than us, but they have, of course, by any means, access to a much bigger knowledge base than any of us humans do individually. And also the agent, in the way it's trained and in the way it's worked, it essentially works best with the solutions that it would itself choose. So let's say it's trained on a base code base, and it will assume that when it approaches a problem, it will automatically assume the architecture and the design that is best represented by the code base it's trained on. So it's typically good code base, and it will choose the best patterns based on that code base. So unless there is a explicit requirement that makes you need to use that architecture, it will be a smoother process if you let the agent choose implementation method based within the restrictions. And also it will be easier to work with that code base down the road, because if you force a design pattern that the agent isn't comfortable with or doesn't understand that fits into that picture, it will misunderstand that every time you revisit it, and it will keep misunderstanding that. So unless it's strictly required, let the agent give the agent some room. And now back to the chat, and let's get the entire thing in here like this. So now we can see it claims that it's done and it's made the TDR header analysis. But before we start looking at it, go back here and go to second prompt, and let's get the agent started with the next step. Oh, what happened here? There we go. So I will simply paste that in here. And it will get to work. And then we will switch to this one. And we will find the TDR header analysis. Let me first close down some documents. And let's look at it in preview mode and move it into a window like this. So this is the AI analysis of our file formats. So it says that it analyzed 90 files, 79 passed, 11 failed. This is the distribution across the test stages, which they're called in TDR. It's looking at the header structure, key observations. Okay, and here we have the mapping, serial number to unit serial, part number, product number, part revision number, product rep, operation type, test stage, and it's doing a dictionary lookup. Sequence name, software name, sequence version, software version, operator. So this looks perfect, but you can see that it has a medium confidence on the software name. Yeah, and you can see it here. So it has a path, not a name, and it suggests extracting the file name from the path. So it's all good. Then we have some optionals. Let's skip those. Header containers, test type, So it's suggesting MISC information for test types, test stage, burn-in times in minutes, position in rack, UT description. Perfect. This looks just fine. And then we have the operation type mapping. So here it has logged in, it's queried the WATS server to get the operation types from the server. And it's suggesting PCBA matches PCBA test, ICT matches ICT test, burn-in matches burn-in test, EOL end of line, HiPot, HiPot installation, pre-burn-in, pre-validation, functional test. So I think that would, that's a medium confidence. I think for some reason it didn't catch that pre-burn-in, but let's say that that's okay. Okay, so this looks like a fairly good analysis. I couldn't find anything to complain about at this point. So now it's working on finalizing the step analysis. And we're actually not that bad when it comes to time. So my hope is at least that we can get the converter compiled and that we can get the tests running and get those reports into the WATS server. And while we're waiting for this now, that's a good thing I could recall that, because now I have something really important. So when doing this, being connected, so first, essentially, the WATS API does not need any authentication when you have the WATS client installed. So you should have the WATS client installed and logged in. But I have to say, I would not dare to do this on a production server. For those of you that have an enterprise account, you can sign up for a free sandbox, because although you can do some, you can be careful, there's no guarantee that you can't ruin any production data. So the most dangerous thing is that you can overwrite existing data. And the second most painful thing is that you can easily clutter things. So if you suddenly run in thousands of reports and something is wrong in the parsing, so they end up with different part numbers, different serial numbers, you're going to have a hard time locating everything and cleaning everything up. So yeah, make sure this works. At least make sure you only send to software debug or something like that before you're pretty confident that things are safe. So that was the WATS clients part, and now it's finalizing the sequence analysis as well. So let's hope that it can complete that one and we can start the implementation phase. So let's prepare. Now now it's finalized. Look at this here, and then we can do in the prompt, we will do please make and implement. No, since the header was so the analysis was so apparently unproblematic, let's skip a step. And what I usually would do here is make an implementation plan that would take the analysis one step closer to implementation, and I can actually verify that the solutions the agent is going to choose are good for the purpose. Let's skip that and now say, please implement the header parsing, create a progress.md and keep track of your progress. This is actually an important point because the agent only has so much context. So as new things and new thoughts and new ideas comes into this chat window, the old ones will slowly disappear in the background. So if you ask the agent to make up a big plan and start implementing it without any anchors outside of this chat, you might risk that it loses the focus on the original task. At least if you need to stop it during that process and correct, it easily can go down a new path and forget where we were actually going. So by keeping a document, having it, keeping that progress document up to date, you will also help the agent keep focus on the task. Yeah, let's leave it at that. So implement the header parsing, create a progress.md, and keep track of your progress. Let's do that, and then we can start looking at the test step analysis. So key findings. So we have the main sequence callback at index 0. We have a step numbering. We have 6 distinct types identified. Numeric pass-fail string. We have 5 values, pass-fail unknown, skipped, implicit done. And we have XY chart data, and we have up to 5 level steep hierarchies. So 4, 23, 3, 4. Step structure, so we have number, we have the type, we have data type, path, name, result, and measurement. No, it's impatient. No, that was the wrong one. Sorry about that. The agent trying to take over my... Okay, for some reason it won't open in the... Yeah, it's because of this one. Okay, so we're back. Implementation phases. Oh, it's progress document is just taking over because it's updating it all the time. So let's try to close that one down again. And yeah, step path. So it maps the sequence to sequence call. It maps numeric limit to numeric limit step, multinumeric to multinumeric limit step, pass-fail step, string value. So this looks very nice. Yeah, it catches the limits and how to map the limits and yeah, pass-fail. So I can't really say I have any objection to this at this point, at least not that we will have time to inspect. And of course, the more complex the task is, the more time and effort you should spend in evaluating this. And when the tasks are really big, a good tip is to AI on the AI. So I can ask the AI agent to make the... First, I discussed with the AI agent about the design we want to choose, and then we decide on one, and then we do an analysis and make an implementation plan, and then we implement. And when the implementation is done, I can do a new agent, new model, and I can start asking that new model to do a more skeptical analysis of the work that's done. And I can ask it to find cavities, gaps, bottlenecks. Is there any problems with what we just implemented? And this is also one of the I'll just have to take a call, 10 seconds. I'm really sorry about that. So now I'm back. Yeah, so that's also what I wanted to say, is that one of the powers with AI agents and coding is that you can actually manage to implement and to use methodology. So in a work environment, in a development team, time is scarce and things takes a lot of time to implement. So corners are always being cut in the things that you know that you should do, but that is not strictly necessary to get the code written. So with agents, you can really quickly refactor, and you can really quickly change around the entire architecture of something. So it enables you to do much more frequent analysis and frequent code reviews, and actually do the good specs and good analysis of what you're going to do. So then you can kind of compensate for the uncontrollable part of the AI agent by applying more methodology. And the great thing is that you don't need to really know that methodology. You can ask the agent to list the top 3 common methodologies used to evaluate a software solution of this kind. It will list it for you, and you can just choose one, and you can ask it to do it. And it works just perfectly. It will give you an analysis, and by shifting the viewpoint of the AI agent, setting the context of that analysis, he will find things that he himself implemented the past before, and he will see it from this different perspective and realize any mistakes, or at least realize some of the mistakes, and you'll have to iterate over it and maybe do that more times to make it perfect. So now it's actually implemented everything, and it's trying to run the tests. It's got some failures, and it's trying to resolve it. And that's also something that's good to know. I would assume that if something fails, the agent will in most cases be able to solve it. So when you download this repo and start, if the startup script fails, if something is wrong, the agent will be able to help you get through it. So now it's building successfully, and phase 1 is complete. So it was not completed the entire implementation phase. Yeah, so we just covered the methodology part, and then we have a next thing that is really powerful, and that makes this type of an agent much more powerful than when you're working with the Copilot in Microsoft 365 or ChatGPT or any of these tools, is that these development environments, they can actually produce their own tools. So I had this yesterday, actually. I was preparing for this webinar, and sorry to say it, marketing, but my official WATS PowerPoint template didn't cut it. So I asked my Copilot 365, can you adapt this template and change the styling, which you would expect the Copilot 365 to do, but he just had a long excuse for why he couldn't do it. I dropped the file into Copilot, and Copilot made Python scripts that did it for me in 5 minutes. Also do the same thing. I can ask Copilot 365. Okay, before I keep on talking, let's look at this one. So now it's saying that the header parsing is complete, and it's suggesting sequence parsing. It's 10 minutes until the hour is passed, so I'm going to skip that, and let's try running a test first. Run all files in data and submit them to the server. If I don't tell it, there are some safeguards in the project that will do the validate for submit and not actually send. But don't trust those safeguards on a production server. The agent will find a way around it if you let it. So submit them to the server. Let's just ask it to do that, and then I'll let that work for a little while, and you'll just have to excuse me for 1 minute. Okay, sorry about that. It was someone forgot the car key, so I just had to hand that over. Okay, so we were in the middle of closing the loop. Yeah, so the big power is that these tools can actually create their own tools when they don't have one available. So one of the things that I also like to do is just open, if I need to reorganize something locally on my computer, I can open that folder in Visual Studio, and I can ask the AI agent to list all the documents, list all my PowerPoints in order based on when they were last edited, and I can have it shuffle them around and edit Excel sheets and so on. So it's a really powerful tool, not just for development purposes. So now it found something wrong. This is something, probably a bug in my template that gives it the wrong namespace for the tests, but it figured it out, and now it's running the test. You can see it's submitting reports. So we can actually go into the account. No. Yeah, that's a good point. This is also a typical trap. If we go look at these files, they are back from 2003. So that's a typical file of failure when you upload historical data, is looking at it with the default current filter. So let's say 2020 to get everything here, and apply the filter, and now we can see the reports are coming in. So let's sort them by test operation. And here we can see that we have the burn-in tests, we have the end-of-line tests, and so on. Perfect. Before we start exploring those, see if this one is done. Oh, it's still running. Let's have a look at one of the files, end-of-line test. Open it. Look at the header, so the serial number, part number, revision looks good. We have an operator. We have the station data, we have MISC information, and we have the subunits. So this was a single prompt, more or less. This would be a couple of hours of manual work. So it's still testing. I was hoping I could get it to start the last implementation to get some sequences in here as well. Let's so there's one file that is failing the conversion. So that's why it's still working on this. Okay, let's let that keep working and go back here. So closing the loop is what it's really about. So we've been interrupted on this a couple of times now, but what it's really about is that if you can make a small contained environment inside your code, kind of like we're doing now, where the agent can design, implement, and run tests that return actual data, and you can evaluate the return data and use that to understand if it is correct or not and improve. That's really a really powerful part of this that should be utilized. So this is all about making the agent able to understand the result of what it's actually doing. And this is kind of scary if you think about it. When the Elon Musk and Jeff Bezos is out there, can do the same thing with their robots. So imagine 10,000 robots training on a task where they can share their knowledge in real time, and they can evaluate their own result and just keep training until they're perfect at a task. It's an intriguing possibility, but also a scary thing. So now it says that it's done. All the tests are passing. Let's just start it on the second phase. I totally get it if you need to leave, but I will stay on at least 15 minutes more to hopefully get some sequence data in there. And if we do, I think we could call this successful proof of concept. So while it's working, let's look at the more small tips. Source of truth is a really complex, a really difficult thing. So when you start developing with AI agent, and you maybe start with a spec, and then you implement something, and as this grows, you need to decide at some point where the source of truth lies. When something deviates, what's the correct place to look? And is that done in a specification or in a contract, or is it done by the source code itself, or is it done? Yeah, how do you choose to do that? And regardless of what you choose, it's going to be a risky topic, because the agent can work on a lot more data at the same time. So a human user wouldn't typically do these kind of errors. But let's consider this scenario where you have an implementation, and then you ask the agent to use that implementation, and for some reason it does it slightly wrong, but not in a way that breaks the code. It just does a bad implementation. And the next time around you visit the same topic, there are two implementations. One is the original, one is the correct one, and one is the slightly failed one. So now you're at a 50-50 chance for the agent choosing the wrong as the source of truth. And then you are in a 2-to-3 relation, and the deviation just grows. And that will make this source of truth drift, and suddenly the agent will interpret the poor implementations as the correct, and it will, even if you're not careful, it will replace your source of truth with the wrong implementation to make it match up. So this is something that needs to continuously be validated and continuously be monitored. And the tools are also evolving, but I would really appreciate a way to lock down things, to be able to say to an agent that you are no longer allowed to change the signatures of these functions or property names. From now on, you can only implement things like that. Yeah, then refactor and redesign. This is kind of like the methodology thing. So compared to conventional coding, where you kind of have to plan and decide things that are not present yet. And you can think of this as like designing a house. So if you're going to build a house, you have some ideas on what kind of house you need, what kind of floor plan you want, what number of bathrooms, and so on. And you have some ideas on what is practical. And your wife probably has too, and your kids probably has too, and that unified impression that you all have on what that house should be is probably not rooted in reality. It's like the design choices in software. It's rooted in old habits, in assumptions, and in misunderstandings of what is actually practical. The problem with building a house is that you have to build the basement and the foundation, and when the concrete is cured and you start building and you realize that this is not going to work exactly like this doesn't look exactly like I imagined it, then changing things is really expensive. But using AI in refactoring and redesign makes it possible to kind of just set up the entire box of a house right away, no foundation or anything, and you can start designing it for the purpose that it has, and you can evaluate and do benchmarking and test your actual assumptions on what is practical and what is valid in the frames of that project. And then you can, within just minutes or hours, refactor the entire solution when you actually have the data to make the correct design decisions. This is, of course, really hard to implement if you are introducing AI to an already existing big code base. But with startup and R&D or early stage of design, I find this a really big strength. So now it's running tests again. Got some failures. Let's hope it can successfully send them. The last do's and don'ts, so validate and verify, can't be done enough. So of course you can do that in different ways, and different approaches fit different use cases. Some of my colleagues like to look at every code change block by block when something is done by the agent. I don't have the patience for that, so I find myself, if I have to do that for a big code base, I will, regardless of if I'm looking at it, I will not really look at it with focus. So I find it better to look at what files are changed and keep track of that, and always do a post analysis of the work. So I will then ask another agent, can you look at these files, the latest updates, and consider it in the context of something that I'm concerned about? Will this create overhead? Will this create security risk? Will this create network problems, or will this create potential race conditions, and so on? It's still trying to build and having some failures. Yeah, this is slightly frustrating. Yeah, now it succeeded. Now we run the tests. Show you another little couple of testing tips. So in the system manager, you have these levels which are useful in these cases, because when I do testing like this, I typically keep a specific level that I use for my test output. and then I drag my client. So this is my machine. Maybe it was in site A yesterday for some reason, if I wanted to upload some report there. But when I do testing, I drag it into this test and debug level. It's not completely safe, but what I can be sure of then is that all the reports that I'm sending now will be inside of this level. So it's easy to identify them. I can find them. That won't stop me from potentially overwriting existing reports inside A and B. The likeliness is low because you'll have to match on both the serial number, part number, test operation, and exact start time, but it's still possible. In addition to this, when we go to the test reports, so, and I hate this report, and probably anyone that had training with me have had me complain about people using that report. But for this purpose, it's obviously really, really nice. So in this list, I can see all the reports. And if I scroll all the way to the right and make sure to enable it here, I have a field that's called receive count. And let's take the report size as well. So then I can see how many times the report has been overwritten. So I can see some of them. One, these are the two sent by the client for test. But I can see here I have 3 for some and 2 for some. So probably it's processing, and some of these have the sequences and some of them have not. So let's open this one. And now we can see that the sequence data is actually in here. It's an ICT test. Looks like, no, that's a functional test. And if we open the entire report, it looks pretty promising. Looks almost spot on, actually. Let's check some other test operations. The ICT, make sure it's a one with 3. Here I have the ICT test. So it's sorted by components, resistors, and so on. This also looks just perfect. And let's do the burn-in. That's a little bit different. Make sure we have one with 3 overrides. Yeah, looks like it's got these 2. Yeah, it looks like everything is more or less spot on. Excellent. Let's just close the loop on this and do please build So I'm asking it to build the converter, so I don't even have to press a button to create the final DLL, build the converter DLL and prepare it for distribution, include documentation. So in the documentation files of the repo project, there is, among other things, there is the typical article or the typical instructions we send about how to install the converter. So that will be included in the package DLLs. So it's making a DLL, a README, and let's open the Visual Studio main window again. So here we have deploy. So here we have the converters. Now it's built both for the 6 client and the 7 client. And yeah, it's creating the docs now. But let's not wait for those documentation files and just start go to the WATS client, and then we're going to go to the converters, add converter, TDR converter, and then we browse for the assembly, and that should be for the .NET 8, since I'm using the WATS 7, and choose to be allowed. Now choose the text file parser, set the input path, let me see, go to WATS, and make a folder here called TDR. Select that folder, and filter is star.tdr, and the post process is move and apply. And now the converter is installed, and hopefully it will start. And then I will do a final test. I can see the error folder has appeared in the TDR folder, and I'll simply copy these files. If everything is working as expected now, they hopefully will be picked up and processed. Oh, seems like some problem with the, oh, now they're back up running. So TDR converter also running. Just make sure I have the right TDR. Take this one more time. Yeah, there you can see they go. They all went to done and on to error. I would absolutely spend more time evaluating and verifying everything in the data, and I would typically do that inside what's in the yield analytics and in the test step analytics. There are several ways you can do sanity checks there by comparing numbers and making sure things are adding up, making sure limits are outside past measurements, making sure CPKs and CP values make sense, and so on. Hopefully this has been useful for you. There will be a shared version of this video available. And just as a side note, of course, if you have trouble with this, we will help you as best as we can in the support. But this is usually not a part of the regular WATS support agreement. So if you need custom help, we're happy to do training, but that would be a service charge by the hour. If something is not working and you need help just getting something to work, how to create a token or some WATS specific thing, that's of course a support thing. But we of course offer doing this as customized training sessions as well. So we've done that for a couple of customers where we spent maybe a day or two, split into several sessions, doing this with practical WATS implementation work. So I guess that's it for today's session. Let me take you back here, and this is kind of what I think is important to understand. So all the knowledge and all the little details that I've been telling about in all of these tools, they are not really that important. It's the communication and your ability to explain in clear terms what you want to achieve that is actually the most important thing to be successful. So thank you all for watching. Hope to see you all, or as many of you as possible, on this year's WATS Up this autumn. So please sign up for that. And if not, I hope I'll probably see you again on Teams over some training session or something like that. So have a nice day, and